Hi, this is Ashutosh, and in this video I'm going to present the solution of this given question. The question simply says that there is a function fx which is a cubic polynomial with leading coefficient unity and such that f at 0 is 1 and all the roots of f prime x is equal to 0 are also the roots of fx is equal to 0. So we have to find that fx. Alright, let's start solving it. So since the function is a cubic polynomial with a leading coefficient unity, it means we will take this function fx as x cubed plus bx squared plus cx plus d. Now you notice that the leading coefficient should be 1 here. So a is just 1. The second information here that f0 is 1, it means when I plug x equals to 0 in this function, of course on the right hand side I will get everything 0 except d, and on the left hand side I will get 1. Therefore this will give us d is equal to 1. So this function is modified to x cubed plus bx squared plus cx, and at the place of d that is be 1. Let us call it 1. Now the other information is f prime x equal to 0 is an equation for which some roots are there, and those roots are also the roots of this equation here. Now let us find the derivative of this fx. So we will have f prime x is equal to 3x squared plus 2bx plus c, and the equation corresponding to this f prime x is just f prime x equal to 0. Now this is a quadratic equation, so for which let us take beta and gamma are the roots. So if beta and gamma are the roots of this quadratic equation, of course beta and gamma are the roots of this cubic equation as well. Why? Because it is simply saying that. So there is a simple side note here. So fx equal to 0 has 3 roots because this is a cubic polynomial. So it has 3 roots. Let us take alpha, beta and gamma, where beta and gamma are common to this quadratic equation. So now you see that if I have this fx equal to 0, I can write it as x minus alpha, x minus beta, x minus gamma is equal to 0. And this quadratic equation in terms of its roots can be written as 3 times x minus beta, x minus gamma is equal to 0. This suggests that this entire quadratic expression is going to be the factor of this fx. So I can now write this fx in another way. It will be like this: fx is equal to 3x squared plus 2bx plus c, and there is one other factor corresponding to the other root alpha. So just x minus alpha. We have written this fx in terms of the f prime x and the other factor x minus alpha. Now let's expand it to give us, so this will give us 3x cubed minus 3 alpha x squared plus 2bx squared minus 2b alpha x, and when c will be multiplied to these two terms, that will give you cx minus c alpha. Now let us collect the terms. So this will be 3x cubed, but the coefficients of x squared will be collected like this: 2b minus 3 alpha, and the coefficients of x will be collected as c minus 2b alpha, and the constant term will remain same. Now comes the important part. This is the first equation or first function, and this is the second function. But notice that these two functions are actually indicating the same entity. In fact, they are representing the same curve. So if two different functions are representing the same function or same curve, that can be possible only if one of them is some multiple of other. So this one of them is some multiple of other can also be written mathematically as 1 by 3 is equal to b divided by 2b minus 3 alpha, c divided by c minus 2b alpha, and 1 divided by negative c alpha. So what I have done here, since they are representing the same curve, therefore their coefficients must be proportional. So that the coefficient of x cube in the first equation is 1 and the coefficient of x cube in the second equation is 3. So that should be 1 over 3, and that should be equal to b over 2b minus 3 alpha. That should be equal to c divided by c minus 2b alpha, and that should be equal to the ratio of 1 and negative c alpha. So we will have these four ratios equal to each other, and from there we have to find out the values of b and c. So first of all, we have to focus on eliminating alpha anyhow. So let's take this as 1, this as 2, this as 3, and let's name the fourth one as 4. You notice that 1 over 3 and negative 1 over c alpha can be equated, of course, because all are equal. So from here I get 1 over 3 is equal to negative 1 by c alpha, and which will give us c alpha is equal to negative 3. Because we need alpha, so alpha will be negative 3 over c, and we will use it in near future. Now we can take this first and second together. So first and second I'm taking together. So we'll get 1 over 3 is equal to b over 2b minus 3 alpha, and from there if we simplify it, it will give us 2b minus 3 alpha on the left, and that will be 3b on the right, which can be further simplified as 2b will go on the right hand side, so that will be b is equal to negative 3 alpha. But notice alpha is negative 3 by c. Therefore, once we substitute this alpha in here, that will give us negative 3 times negative 3 over c, and so we will have one relation between b and c as bc is equal to 9. Let's save it for the future use. And another equation can be also found by just taking second and third ratios together. So we'll take the second and third together, and notice that if we take them together, this b will be multiplied to this c minus 2b alpha, and c will be multiplied to this 2b minus 3 alpha. So just to make it simple, we can write it b times c minus 2b alpha on the left, and c times 2b minus 3 alpha on the right. Let's open this. So this will be bc minus 2b squared alpha, and here will be 2bc minus 3 alpha c. This bc can be taken on the right. Let's take this negative 3 alpha c on the left. So this will be 3 alpha c minus 2b squared alpha is equal to 2bc minus bc is just bc. But notice BC we have already discovered, that is 9. So let's just substitute it in here. And also alpha is just negative 3 over C. So I'm going to substitute that thing also. So negative 3 over C at the place of alpha, C will remain same. Then 2b squared and again negative 3 over C just to replace alpha. And BC is 9. Let's do some simplifications. Of course, C and C will cancel each other. And 3 times negative 3 will give us negative 9. And here that will be negative 3 over C multiplied with negative sign here. So it will be positive 2b squared, not 2b squared. That will be 2 times 3, that is 6 b squared over C. And on the right hand side, that is 9 only. So of course, we can see that it will be 6b squared over C is 18 by taking this negative sign, negative 9 on the right. And again we can multiply C throughout. It will give us 6b squared is equal to 18C. And further, this 6 cancels this 18. So b squared will be 3C. But notice here BC is 9. So why not we can simply substitute one of the value there. So let us just substitute the value of B from here as 9 by C. So that will give us 9 over C whole squared is equal to 3C. Let me scroll a bit. And so there will be 81 is equal to 3C cubed. So dividing by 3, that will be 27 is equal to C cubed. And so C will be just 3. Also, we know that the product of B and C is 9, and we know that the C is 3. So of course B will be also 3. So we found out the values of B and C, and that's the solution, because we have to just substitute those values in this function what we are looking for. So let's do it here. Let me erase this thing. So if I just plug this B and C here, it will give us x cubed plus 3x squared plus 3x plus 1, and that's the answer. That's it. So thank you for watching, and see you in the next video with some other interesting problem. Thanks.